Today in this video, we are creating the shield of Captain America. Here we first model the shield and apply the materials. Then we will render this shield with both EEVEE and Cycles engines. At the end of this video, we will see how to get an effect similar to the EEVEE bloom effect for Cycles rendering. Alright, let's get to work here. First, clear the viewport and add a UV sphere. After that, open the Add UV Sphere panel below. And let's increase the resolution of the sphere through this panel. So, now multiply the segments and rings by 4 here. You can also do this by subdividing twice through the subdivision modifier. But the benefit of subdividing through this panel is, it will apply this setting to every UV sphere you add to this project from now on. So, do not confuse it. Of these methods, use the method you like. After subdividing, we now need to cut out this sphere to make the shield. To do this, first, switch to Edit mode. Here we allocate a height of 15 vertices from the top of this sphere for our shield. Doing this by counting and selecting these vertices one by one is a difficult task. So, let's use the Overlays statistic option for this. After enabling this, the top left corner of the viewport shows the details of the objects in this viewport. This is the number of objects in the viewport. And this is the number of objects we have selected here. Here is the number of vertices, edges, and faces in this UV sphere, and the number of selected ones. This is the number of triangles available here. Now that we have selected this object and are in edit mode, so all the vertices, edges, faces, and triangles shown here are relevant to this object only. When we switch from edit mode to object mode, all the details mentioned here are displayed for all the objects in the viewport. Now we want to take a height of 15 vertices from the top of this sphere for our shield. For that, now, select the top vert here and turn to the front view. Then, now press the Ctrl key and select a few verts right down. Now you can see the number of selected verts in this statistic. Here are 15 verts selected from the top. After selecting 15 verts, now select the vert below it. Then, hold down the Alt key and click on the right side edge of this vert. After doing that, you can see that a column of verts is selected horizontally around this sphere. Now delete these selected verts. After deleting, you can now select the lower part of this sphere by pressing the L key. Now select and delete that section. After deleting it, now switch to object mode. This part we have just created is the base mesh of our shield. Okay, now smooth the shading here. You can see that the origin here is far from this object. So, let's set this to the center of this object. Now half of the modeling work on the shield is done. Now, rotate the shield slightly and place it on the viewport ground. After that, now let's give this mesh a little thickness. For that, add a solidify modifier to this. After adding it, now add a split edge modifier to prevent smoothing of the edges. Now apply these modifiers in order from the first one. Okay, now add a plane to the viewport ground and multiply it 16 times. We no longer need this overlays statistic here, so disable it. Now, let us create materials for the shield. This requires simple lighting first. So, add a point light and then turn the viewport to rendering. Now hold the light slightly above and in front of the shield and give it 200 power. To start to create the material here, first split the viewport into two parts. Then turn the right side viewport to render view and hide the toolbar and gizmo here. Now turn the right side viewport to shader editor. After that, now select this shield and create new material for this. Now rename this as Shield Base Metal. We first create a basic metal material for this shield. After that, we will give the relevant texture for the front part here separately. So, let's make the metal material. First, give one for the metallic value of the principled shader here. Here, we will create and use a roughness map for the roughness value. Now let's create it. First, add noise texture and connect it to the roughness here. Then, add the texture coordinate node and connect its object vector value to the noise texture. After that, add a gradient texture to this vector connection and set its color blending style as quadratic sphere. Now let's change the values of the noise texture. Enter 400, 16, and 0.8 for scale, details, and roughness here respectively. After that, add a color ramp on the factor output of the noise texture. And enter 1 for the V color value of the first color stop here. Now change the interpolation here to B-spline. Enter 0.123 for the V color value of the second color stop here. And give 0.6 for the position here. Here is the roughness map now we created. If you want, you can select and frame these roughness map nodes. Now to complete this material, set the anisotropic and anisotropic rotation values of the principled shader to 1 and 0.25 respectively. Changing these values will not change the shield in the EEVEE engine. But in the Cycles engine, these anisotropic values show changes in the rendering. We have to render this shield at the end with both EEVEE and Cycles engine, so this material has to be set for both engines. Okay, now let's create the material for the front part of this shield. There is a star symbol in the middle of Captain America's shield. Therefore, we need to add such a symbol to our shield as well. First, we need to create a UV map of this shield for that. So, now switch this shader editor to UV editor. Then, select the shield and switch to edit mode. We create this material only for the front part here. So, let's generate the UV map only for the front part. Select only the front part of the shield using the L key. Then, open the UV mapping menu and select Unwrap. Right now, we have unwrapped the UV map for the front part of the shield. After that, let's start creating the material for this part. So, switch this UV editor to shader editor. Then go to Materials Properties. And create a new material by keeping this shield in edit mode and the front part selected. Now rename it as Shield Texture and assign it to this selected front shield section. This shield texture material is now used only for the front part. The shield base metal material is applied to all the remaining parts of the shield. Okay, let's start working on this material now. First, add a color ramp and connect it to the base color of the principled shader. Then, now add the gradient texture and connect its factor value to the color ramp. And change the gradient type here to spherical. Now add the texture coordinate node and connect its object vector value to the gradient texture here. After that, now let us set the values of the color ramp. Change the interpolation here to constant. You can now see how the black and white color separates when the position of this second color stop is changed here. Now, we are going to use this to create our color rings for this shield. Now set the color value of the first color stop to red. Then, now give 0.42 for the position of the second color stop, and set the gray for the color here. Now add a new color stop, and give 0.54 for the position here. Leave the color value here in red. Now add another color stop and set the position here to 0.65. And set the color blue for this, using the HSV color values shown here. After setting the color ring, let's add the star symbol here. In the video description, the download link of the star symbol texture file is given. Download it and add it to this node setup. You can drag and drop this texture file to this shader editor. Now connect this texture to this color ramp using a Mix RGB node. Then, now select the screen for blending mode here and give 1 for the factor value. Okay, now let's place this star symbol inside this blue circle. We can do that using the UV map. Before doing that, select Extend for the extension in this texture. Also, if you want, you can attach the UV vector of this texture coordinate to this image texture. But this connection does not make any difference to this texture. Normally the UV vector is the default vector of all the textures in the Blender. So, providing the UV vector connection through the texture coordinate does not make any difference here. After all, now open the UV editor and switch the object to edit mode. Now select the full UV map here and disable the overlay in the left side viewport. By doing this we can clearly see the texture. Now place this UV map in the center of the texture. After that, scale this UV map 2.3 times. Now enable overlays here and switch this side to shader editor. Now we have just created the color map of the shield. As we mentioned earlier, this image texture has a default UV vector value, so this connection is not required. You know we changed the extension of this image texture earlier. Now switch it to the previous repeat option. After changing this option, now you can see how the star texture repeats and appears on the shield. This is why we changed this option to extend. This extend option prevents the texture from being repeated. Okay, now select all the color nodes related to our color map, frame it, and name it as a color map. Before we do the rest of the work on this material, let's add more lights to this shield. There is nothing special to do about this. Duplicate this point light we set earlier and place it in a few random places near the shield. After setting the lights, now give 1 for the metallic value of the principled shader here. You can now understand why we added more lights. When the metal value is set for the shield gives a glow effect when the light comes from different places. So, try to change the placement of the added lights as much as possible. Okay. Now give a value of 0.3 for the roughness value here. Giving roughness in this way gives the same roughness to this entire texture material. And using this kind of roughness value does not make our shield look better. So, let us create a roughness map for this roughness value. To do this, first, add the noise texture. It is difficult to create this roughness map by applying it directly to the material. Therefore, we will use the Node Wrangler add-on here to see the details of this roughness map. You can search for the name of this add-on and enable it in Blender add-ons preference. After enabling it, you can use it in the shader editor using Ctrl and Shift hotkey and click on the relevant node. Then you can get the preview related to that node like this. OK, now using this preview and create the roughness map we want. Now add gradient texture to this and connect it to the vector value of this noise texture. After connecting, change the gradient type here to quadratic sphere and connect the object vector here. After that, now give the values as shown for the scale, details, and roughness values in the noise texture. Next, add a mix RGB node to the out connection of the noise texture. And then connect the color ramp output of the color map to it. To further adjust the texture attached to the mix shader, add color ramps for each of these in connections. After adding that, now change the blend mode of this mix RGB node to difference. And then set the factor value of it to 1. For the first color ramp, switch its interpolation to B-spline. And now, set its first color stop to white color. After that, set the second color stop position to 0.370. And then change its color V value to 0.575. Now, switch this color ramp to B-spline interpolation. And change the first color stop here to white. Change the second color stop to black. And then set the position of it to 0.127. Now we have created the roughness map of this. Let's connect this roughness map to the principled shader. This is the shield with the roughness set by giving a value of 0.3. This is what this shield looks like when using a roughness map. You can see the difference between the two. Now select the nodes related to this roughness map. Frame them, and then rename it as roughness map. Next, we have to set the normal map for this shield. To do this, first, add the wave texture and connect it to the node viewer as before. And connect the object vector to this texture. Now change the wave type to rings and the rings direction to spherical. Then enter a value of 85 for the scale value and 0 for all other values here. After setting these values, now add a bump node for the color output of this texture. Then connect the color output of the texture to the height input of the bump node. Now set the strength value to 0.5 and the distance value to 0.2. After changing these values, add a mix RGB node to the color out connection of this texture. And connect the star texture we used earlier. Now set the node preview for this mix node. Then, now add color ramps to these two connections. Before changing the values of these color ramps here, set the blend mode of the mix node as screen. Then, give a value of 0.09 for the position of the white color stop here. By changing the values of this color ramp, this star texture is now displayed separately without mixing with the other textures. Next, let us set the values of this color ramp applied to this wave texture. Select the first color stop here and apply these values shown here for these color values. After changing these color values, the node preview does not show any details related to the wave texture. But you can see this when you look through the bump node. This is because the depth we used for this wave texture is very low. Right now, we're done creating the normal map. Let us now connect this to the principled shader. Now select and frame our normal map nodes, and then rename the frame as normal map. Here is the node setup we created for this shield. Now finally change these anisotropic and anisotropic rotation values in the principled shader. As mentioned earlier, these values make no difference in EEVEE rendering. But this works in Cycles rendering. Now let's close the shader editor and render this shield. To do this, first, add a camera to the viewport and position it. After that, now enable ambient occlusion, screen space reflection, and bloom render settings. Adjust the intensity value of this bloom to 0.005. Next, set the render region to the area where this shield is located and enable the crop to render region option in the output properties. Now let's render this. This is the render output our shield in EEVEE engine. Now, let's render this using the Cycles engine. First, switch the render engine to Cycles. Then set the render settings here. Multiply the number of samples in the render sample by 2. That is, give 256 samples. And then enable adaptive samples. We do not use any denoiser for this rendering. For the tile size, if you are rendering using a CPU, set the tile size to 32. If you are using a GPU for rendering, set the appropriate tile size for that GPU. Now let's render this. You know, like the EEVEE engine, the Cycle engine does not have a bloom render option. But we can give a similar effect to this bloom effect using the Blender compositor. So, let's see how to apply this bloom effect to this rendered image. For that, now switch the viewport to the compositor. Then enable the use nodes at the top. And then enable the backdrop feature. Now connect this render layer to the viewer. Then, add the glare node on the viewer connection here. And change the glare type here to fog glow. Now let's change the values here and try to get a bloom effect similar to EEVEE. These are the filter values that give the closest view of the bloom effect of EV by compositor glare. Now connect this glare filter output to the composite node. Now, this filter is applied to this scene every time you render. Remember this, disable the use nodes in this compositor when rendering with the EV engine. If not, this bloom effect also applies to EV render output. So, you can use this use nodes option to disable the composition process. Now here is our final render output of cycles. And this is the final render output of both engines. I hope you have learned something new from this video. If you like this video, hit the like button. If you want to watch more videos like this, subscribe to our channel, click on the bell icon on the side, and select all. This will allow you to receive notifications for future uploads. If this video helps your Blender work in any way, don't forget to comment on how. If you have any other issues with this video, please comment as well. And if you would like to support us, please share this video with the Blender users you know. Learn with IBN.